This section is dealing with graphing linear inequalities in two variables. So this is going to be much the same as our graphing linear equations in two variables. We just need to determine which region or regions to shade. Okay. Then the next part is, well, what happens if we have linear inequalities that are systems of inequalities? So first, let's just take a look at a standard example when we have just a regular old equation. So let's suppose that they gave us y is greater than or equal to 3x minus 2. Okay. So if y is greater than or equal to 3x minus 2, note that this is in slope-intercept form, so we can simply start graphing. Now, for inequalities, it's going to be much the same. The only difference is check to see if it is a strict inequality or if it is less than or greater than or equal to. Okay. In this case, we note it is or equal to, so that means when we graph it, it's going to be a solid line. So if it's less than or equal to, or if it is greater than or equal to, this is going to yield a solid line. Okay. If you have your strict inequality, that is going to be a dotted line. Okay. So let's start here. Since it's in slope-intercept form, we can start with the y-intercept 0, negative 2. So I'm just going to start. That's my first point. Now my slope is 3. 3 is, of course, the same as 3 over 1. So I'm going to go up 3. 1, 2, 3, right 1. That's going to be my next point. Now I'm just going to connect these with a straight line. And since this is a strict inequality, that means that it's a solid line. Okay. Now, the key difference here from graphing lines is we need to determine which region we are going to shade. Okay. So when we are dealing with regions that we need to shade, we'll just note if it's y is greater than, we will shade above the line. If it's less than, we will shade below the line. That's why I think it's a good idea to get this into slope-intercept form like we have here. That is to say, y is greater than or y is less than. So then you can just look here directly. So I'll just shade above this line here. Okay. So that is my region for y is greater than or equal to 3x minus 2. Okay. Now, let's take a look at another one here. Let's do one where they do not tell us directly, or they don't give it to us directly in slope-intercept form. Let's say 3x plus y is strictly less than, let's say, 2. Okay. So now what I'm going to do here is I'm just going to rewrite it over here. 3x plus y is less than 2. We need to go about solving this, so I'm going to subtract 3x from both sides here to get it into slope-intercept form. This will give me y is less than negative 3x plus 2. Okay? So y is less than negative 3x plus 2. This is going to be the inequality that I'm looking at here. Now again, note, this is a strict inequality. That is to say, there's no or equal to. So it's going to be the dotted line because the line is not included in the region. Okay? So we start at 0, 2. So I'm just going to fill in my dot here. Then my slope is negative 3, so I'm going to go down 3, right 1. Now, connect them with a line. Feel free to use a straight edge or something like that. Unfortunately, with my tracking tablet here, I'm not able to get that quite as well as I would like, but that's all right. So now, I need to shade below because its y is less than, so this is going to be my region here. Okay? Hopefully that makes sense to everybody. So our basic key is to simply graph and go from there. Now, what happens then if they give us a system of equations? Okay? So when we are graphing a system of inequalities, rather, I'm going to go about graphing it like this. So I have x minus y is greater than or equal to 4. X plus y is less than or equal to 6. Okay. So I'm going to go ahead and rewrite each of these in slope-intercept form. So I'm going to start over here with this one. So to do that, I'm going to subtract x from each side. That gives me negative y is greater than or equal to negative x plus 4. And I'm going to take the opposite of each side. Now remember, if you take the opposite of each side or multiply or divide by a negative, this will give you a reversed sign here. So it's going to be less than or equal to x minus 4. Okay. So that's my first one here. Now for this one, I just need to subtract x. We get y is less than or equal to negative x plus 6. And so that's what I have here. Okay. So now I'm going to go ahead and just start by graphing one at a time here. So y is less than or equal to x minus 4. So that means I go to 0, negative 4. So 1, 2, 3, 4. Then my slope is 1, so I'm going to go up 1, right 1. There's going to be my graph. Okay. Now, I need to shade below that. Now, the way that I'm going to do this is I'm just going to make these vertical lines here. The reason why I'm going to do that will become apparent in a little bit. Now, the next one is negative x plus 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Slope is negative 1, so down 1, right 1. Now I'm just going to put a couple more here just so I know, just so I can get a little bit more accuracy with these. Okay, so these are my regions here. So this here, and then I also need to be less than this, so I'm going to do a horizontal line here. Okay. Now, the region that we are going to use here is we're just going to check to see what's my region where both of them happen. Well, here, if one's horizontal and one's vertical, I'm looking for the checkerboard pattern. So you'll note it's this region here. So I'm just going to go ahead and regraph it over here. And then I'm going to do the same up here. Making sure I'm a little careful here. On those previous ones, I didn't have to be as careful, but for this, I want to get a little more accuracy here. And I know it's going to be this region here. Okay, so this is the solution to my system of equations. Now, you'll note that when we are graphing for systems of equations or systems of inequalities, I mentioned that the main thing that we're going to use for those is a graphing software, just because the accuracy loss that we get is substantial enough that we really do want to be using some software to make that actually look right. So for these systems, this is kind of the basic idea for how you would do it, but for the homework, all I'm expecting for you to do is to just graph it on Desmos and then just take a photo of what your graph looks like for that and then just attach it with it. So let's go ahead and see what it looks like if I'm graphing these on Desmos. Alright, so I have gone to desmos.com. Let me just make sure that people can get that website down here. Desmos.com. It's a free graphing tool that we can make use of, and this is really the way that I recommend that you go about this. So for this one here, we had x minus y is greater than or equal to 4. So to do greater than or equal to, you'll do the greater than sign on your keyboard. Then you press the equal sign after that. So you'll note that after I press the equal sign, it put that little bar underneath there. And then I'm going to put my 4, enter, going to do my second graph here. X plus y is less than or equal to 6. And then we'll see that this region here, which has both the red region and the blue region, this here is my solution region. Okay? Hopefully that makes sense to everybody here. So let's go ahead and take a look at another one here. And you'll note that with Desmos, these graphing ones become pretty trivial. So that's one benefit that we get when we're making use of this graphing software. So I really do recommend we use the graphing software for systems of inequalities. For regular inequalities, you should be able to go ahead and graph these. Now you can do this by hand if you so desire, but I really think that the loss of precision is not worth it for the handmade graph. So let's do another one here. Let's say I have x plus y is less than or equal to 4. So x plus y needs to be less than or equal to 4, so I'm going to do my less than, and then I'm going to press my equals, and that puts the bar underneath, 4. Then I'm just going to press enter to get my second one started. And then I do y is greater than or equal to 2x minus 4, so y is greater than or equal to 2x minus 4. Okay. So the region that we're looking for, the solution region, is going to be this region here. Okay. And in fact, they even give you this little point here, which is where these two graphs intersect. Okay. Hopefully that makes sense to everybody here. So our basic idea is to graph each inequality, find where they intersect. That intersection is going to be their solution for the system. Okay. Let me know if you have any questions or you want to see any extra examples on these types of homework problems. Otherwise, see you in the next video.